Hello everyone, my name is Avkash and you are welcome to another tutorial where we are going to use data engineering, machine learning and several other technologies to work on the worldwide wildfire problem. And today we are working on one very aspiring project related with wildfire problem in all over the world. Every year, United States and several other countries lose significant amount of green forest due to wildfires. This project is divided into two parts. In first part, we are going to use the NASA satellite data to collect a country-specific wildfire data. It means we are going to learn how three different satellites uses two separate instruments called MODIS and VIIRS. So these two instruments collect satellite data and process it to generate the wildfire specific data set. So using these two instruments, the data is generated, and that is what the worldwide forest and other agency use their data to control and predict the wildfire routes or wildfire location in coming days and weeks. We are going to use the exact same data set. This tutorial will be divided into two parts. First, we are going to generate the data for a country, and we will use this code to generate the data set for any country where you would want to create the machine learning model. That will be first part, to generate the data and visualize it using Jupyter Notebook, Streamlit, Kepler.gl and other graphics libraries and applications. In second part, we are going to use the data generated in the first part of this tutorial, and we are going to apply the machine learning algorithms and other methods to predict the wildfire behavior in certain location. Before we start, I would like to inform you that this whole project source code is available at this public repo named Wildfire in this ProdRemp account. Here you are going to get all the information related with this overall project, such as data set creation, machine learning, model management, Streamlit application for data visualization, as well as for the machine learning application. So everything related with this project will be available at this Wildfire location. And here you are going to get all the source code, Jupyter Notebook. So please definitely make sure to visit here. Second, I have also created this California wildfire data set, and I will be updating this data set on monthly basis. So if you just want to get the data set, you can directly access this data set here, because data set will not be available at the GitHub repo because the data set files are really very big. So most of the data set will be available at this Kaggle location, where I will be uploading the data set for the California wildfire as well as for the United States wildfire data set. And this data set is actually created with the project which we are going to talk about in this today's tutorial. So now let's learn where and how I am trying to get this data, which we are going to build in this project. Is coming out from the NASA FIRMS, Fire Information for Resource Management System, in collaboration with NASA. So just to understand very quick that you are going to see the active fire in the North American region, including United States and Canada. You can visit that from this website, and you can also look into the simple versus the time-based. And you are seeing two things here. One is VIIRS and second is MODIS. So these are the two different equipments. So VIIRS is the Visible Infrared Imaging Radiometer Suite, and that is available on this SNPP and the NOAA 20 satellite. So I think the representation for this one you are going to see in the data set as a letter N. So VIIRS spectrometer is, or whatever it is, a spectroradiometer. This hardware is used to collect the fire related data, and that is on board in this satellite. And this MODIS, which stands for Moderate Resolution Imaging Spectroradiometer, which is actually located on this Aqua and Terra satellites. So these two equipment or instruments, they collect the fire related data onboarded on these three different satellites, and that's what we see in our data set. Similar to United States, you can also see the Fire Map Global. It means the data set, what this system has, FIRMS, it has the global fire data at any given time, and they are collecting this data since last 2020, means last 20 plus years. But depending on the type you are going to choose, whether it's a MODIS or you are using the VIIRS, there are limitation because some instrument are only available in last 2 years or maybe last 8 years. So that we will also going to learn. Next, if you would want to download the historical data, you go to archive download here, and that's where I have downloaded all the data, and you are going to select whether you want to download the MODIS instrument data or you want to download the VIIRS instrument data. If you look into the MODIS, you could see that for all countries it's available since 2000 all the way till 2020. So that's the MODIS instrument data. If we go back, look into the VIIRS, as you could see here that VIIRS data is available since 2012 and is 2021. This is archive data, but the regular data in 2022 is also available, but it's gonna come soon. They are still working right now, and that data belongs to all countries here. So whether your requirement is for one country or all, you have to download all the data and then you can filter this out. So let me show you. So here I have downloaded all the zips from MODIS instrument for all 20 plus years, like 2000 to 2020. And here is VIIRS for all countries. And when I downloaded it and I unzipped it, all that data is unzipped here from MODIS. This is year-wise data, and here is data for the VIIRS year-wise data. And if you look into these files, they are created for each country. No matter how you do, the MODIS 2020, then country name, and same thing VIIRS, SNPP, and then year, and then country name. So that's how the data is being created in archival mode. However, if you go back to the archive download, you will see that the older data, so for example, if you want data in 2021 which is not available, you have to create a request. So you could create a request from here. That's how you are going to get the data for your need. And if you want active fire data for example, United States and Canada, here you could see that if you need any data which is more than 7 days, is available in archive where we went there. But in this page, you can get up to last 7 day worth of data, and depending on which format you want. And they have Canada, United States, Alaska, 7 days, 48 days, and 28 days. And you can use the MODIS or VIIRS active fire data. And here is more details about if you are looking into. So because we are looking into the CSV files in this project, so that's what I will be focusing on. After you have collected all that data, we will be using all that data and processing in the Jupyter Notebook using Python programming language to generate our United States wildfire data, and then California state only wildfire data. And we will also try to take the same example to generate one country data and see that how our code works out for any other country also. So I already have the Jupyter service running on this machine. So first I will be looking into this wildfire creation data, Jupyter Notebook. And here we are going to create the USA specific wildfire data, and then we will also trim down our data to be more specific to the California state. So some of these resources which I took help, these resources are from IBM Wildfire Challenge, H2O.ai Wildfire Challenge. I looked into their GitHub code to understand how they prepare the data, how they really put together these competitions. So they definitely helped me to create this whole tutorial. So I do appreciate all of their work. And for data collection, we actually already looked into this location where all that data set was available for us. And here is the disclaimer that please do not use this data set for the preservation of life or property, because this is just it's a near real time. It may not be actual real time data set. So now we are going to start our exercise. First, we are going to import all these required libraries for this project. And I will be showing you where I am running and where this data set I have already downloaded. So the zip files are already downloaded here, and the wildfire data folder has all the MODIS and VIIRS files. If you look into MODIS, you can see year-wise data. If you look into the VIIRS, year-wise data. Next, we are going to use this glob library to read all the CSV files available in this wildfire data folder recursively. As you could see here, all the CSV files are loaded here. And if you look into total, about 6,431 CSV files are available, and it's just a list. So what we are going to do is that we are going to filter all these files list based on United States keyword. And as you can see here, that for each year we are getting United States, we are getting United States Virgin Island, United States minor outlying islands, and that's kind of data we have. So if you just want the United States, all 50 states area, like the mainland area, we can filter this files to United States.csv, because that's kind of pattern we are seeing here. So we filtered out, and now we have got this data which belongs to VIIRS satellite from 2012 to 2021, and for the MODIS satellite from 2012 all the way to 2020. It means that we have all the data in these selected files related with United States wildfire. So now what we are going to do is that we are going to look into that each MODIS as well as the VIIRS data set to understand how the data available in these files and if there is any discrepancy or not. So I'm reading one file and there was some warning, so I just followed that. Okay, use the low memory equals false, warning is not there. And this is the data set looks like from VIIRS. So you have latitude, longitude, brightness. We are going to look a couple of these columns or features in details coming soon. So here we have satellite, instrument, and confidence. So okay, and then version and bright. They have TI4, TI5, and then FRP, day night, whether this data was collected during the day or night, and the type. And here is this acquire date and the acquire time. So acquire time is like a 727, 124-hour clock. So let's look into this satellite. So data is coming out from satellite N, and instruments are VIIRS. We look into the confidence. So confidence value is a string, and there are three different confidence value: N, H, and L, low, high, and neutral. And rest of the information here we are going to study little late, because that's the only one big discrepancy we have found. So I wanted to notate it out. Now we are looking into the MODIS data set, reading it. If you look into that, the data set here is also available, and field like there is a bright T31. Here you see that bright TI5 and TI4. longitude, latitude, acquire date, acquire time, satellite instruments, and the confidence, and FRP day-night type. If you look into FRP day-night type, so confidence here is the numeric. So let's look into satellite. It's a Terra and Aqua. Instruments, MODIS. And here we can look into the confidence is a numeric value. Previously we have seen that it's a string. And here the values are between 1 to 100. Versus in the VIIRS, these values are in 3 different labels: low, high, and neutral. So what we are trying to do is that we are trying to read this data and selecting the values from each file. However, depending on the confidence, if the confidence value is a string, we are replacing low with 0, neutral with 50, and high with 100. So we could match some of these values related with other data set. Next, what we are trying to do, we are trying to parse each file and making sure that we are able to get some of this information like the satellite related, instrument related. So let me run this code first, and this code is reading all the files. So there are about, if you look into all US files, about 31 files we have. So these 31 files are being read one by one, and we are going to get about 680, so 7.6 million rows out of United States 2020 all the way to 2021 data set. And here we are reading the path file, number of rows in each file, number of columns. So you could see that number of columns are same. And we are reading the satellite instrument. So MODIS versus VIIRS, you are getting an idea. The version, the latitude, longitude, and the number of satellites and the days. So that's what we have calculated, and I found this code snippet from the H2O.ai wildfire competition. So I used it and I changed it to make us work depending on our need here. So what we have done, we have taken the data from all of these 31 files and we have stored in this FireDF, and we are keep appending this FireDF. So we are reading a data frame, we are collecting some of the information so we could see here, and then we are appending that data frame. So slowly the Fire data frame has the collection of all 31 files. We can validate that here, and as you could see here, this is a list of all 31 files. So we will try to concatenate and create a new data frame called US Fire data frame. And this US Fire data frame has same number of rows and 17 columns. Let's look this data set for the sample. So here you can see that we have all those columns. So like remember, there was only one difference, was that one place there was a bright T31 and other place there was a bright TI4 and bright TI5. So there are total 17 columns here, and most of the values are available in both of the data sets. So this is our US Fire DF is our real data frame, and we can look into the sample. So there are total 7.6 million rows we have in this data set. Now we are going to sort this data set on acquire date and acquire time. So this is our data set which starts from 2000 all the way to 2021. Here we have. Now we look into the confidence, and as you could see here, the ambiguity between the confidence is solved. Now we have confidence value, it starts from 0 all the way to 100. Now we can look into some of the features available in this data set. So for detailed feature set, you can always go look into here and study this website, and you are going to get a lot more information which I will not be able to provide in this tutorial. So what is a brightness? So brightness is a channel 2122 brightness temperature of the fire pixel measured in Kelvin. So that's what you are going to get the brightness value. And you can look into the US Fire DF. This is our brightness value. Satellites, as you could see here, that the instrument used for this data set is MODIS and VIIRS. And the satellites here is like a Terra, Aqua, and N. I really didn't go deeper into to understand which satellite what, because that was not part of this tutorial. So bright T1 is a channel 31 brightness temperature of the fire pixel measured in Kelvin. So something similar to that. So channel 2122, and here is a channel 31. Same thing TI3 and TI4. So we can look into TI31, and here you could get an idea that what the values are here. So FRP stands for fire radiative power, which depicts the pixel integrated the radiative power in megawatts. So this is what you are seeing in FRP value. Type, so US fire type, there are 4 values. 0 is presumed vegetation fire, 1 is active volcano, 2 is static land resource, and 3rd is offshore. So if you would want to create a data set, you can definitely filter either here, or because if 1 is active volcano, you would want to remove it from your data set. But in this data set, we are keeping all these values. The confidence is a very important field, because this value is based on a collection of intermediate algorithm quantities used in the detection process. So confidence is between 0 all the way to 100, really gives the idea whether this is a fire or really not. So this value is intended to help users gauge the quality of individual hotspot or the fire pixel. So what you see red over there is really fire or not, you can get based on confidence value. So confidence estimate range between 0 to 100%, and you have 3 classes. So you have low, nominal, or high confidence, which is also depending on 0 to 1. So if you are trying to model this data depending on your need, you want to put in buckets, you have ability to put into the bucket based on 0 to 20, 22, 40, 5 buckets. So it's all about yourself, how you'd want to model this data. For that reason, when I have pushed this data set to Kaggle, I kept the confidence value as it is. So user will have ability to model this data if they would want to model it differently. So that was the confidence value. So the combined data set US Fire DF has all these values. So this is the final data set which we are seeing, which is the US Fire DF. So depending on your need, you could actually build your own data set like what I'm really building right now. But for this example, I have selected some of these fields here. And I'm using the confidence.max and then resetting it. So group by on these columns. So we will take this US Fire data frame and create a new data frame called daily fire DF, and we will use these fields to group by. Now we can look into our data frame. So depending on these given fields, here we have the data frame with these fields, and here is all the number of rows. So as you could see here, that 2.4 million rows are available for us in 9 columns, because we are using 9 columns. For your need, you can select other fields too. Now what we are trying to do is that if this whole data set is also having the confidence, so if we look into confidence value from 0 to 100, so if the confidence is under 50, it means that you are really not sure whether the value you see or whether the point you see on the map is fire or not. So we are filtering this whole data frame for all the values which are equal to 50 or above 50. So now we have got this filtered data frame, which we can look into and see that this is about 1.9 million rows. So out of 2.4, we have reduced almost 20% of the rows. Now we can look into the confidence. So confidence from 50 and above all the way to 100. So that's what we have right now. So at this point, if somebody would want to create a data set all the way from 2000 to 2021, they can actually create a data set and they can save it. So here it's just an idea. If you would want to create this data set, you can create compressed version and you can save it on the disk. So we can look into here. This is our file. So USA daily fire from 2000 here, and that file is about, this one is 25 meg. Which is a pretty large file for us to process it. Now we can look into the min and max, and here we could say that there is a min value is max value is here. So now after we have got this USA fire data set, if we would want to just create this data set only for CSV, if we just want to create the CSV, we will not compress it, and let's see how big the file is. So here is our file, which is about 104 meg. So what we could do is that we can take a look of this file and we can use this utility called Kepler.gl, where you can actually load any data set within the limits and you can play with it. So let me come here. That's our data set, and here is our US daily fire, which is about 109 meg. Let's see if it accepts this. So this is a USA daily fire. So Kepler.gl is publicly available data utility for the graphics. So here you could see that this is what we are seeing here. The fire for the United States and Hawaii, all three things you could see. And I won't be going a lot more about the Kepler.gl, but you could actually add the filters here. You can select a field. So you could say that if you are just trying to filter this value only for depending on confidence, and you can say that, okay, just show me the value which are almost 90 or not. So here is the value 152. You can actually filter all these values to 90 here, and your map will be updated. So this is the exercise you could do by yourself. So we made sure that yes, the data we have created and saved that definitely belong to United States fire, and which we have validated from all these three area graphs. Now we need to filter this data based on California. So what we could do, we could actually filter this data set based on California longitude and latitude. So here is the Netstate website where I found that the longitude and latitude range for the California is like this. So we are going to take these values and we will create a range. So CA latitude range is 32 to 42 north, and the longitude range is gonna be minus 124 to minus 114. So because this is a west, so we need to go smaller to bigger. So minus 124 is smaller than minus 114. So we have created these range, and now we are taking this daily fire data frame and creating the California daily fire data frame, and we are filtering these latitude. They must be between the latitude range, and as you could see here that we got about 933,000 rows based on that filter. Now we are going to filter based on longitude range, and here we have about 221,000 rows for our California only. Let's look into our data set. So this is the just description about data set. Let's get the D types. And as you see here, that acquire date is object, it means it's string. So we need to convert that to a data, date and time. And now the acquire date is actually date and time, and we can actually validate this thing again by checking this thing again, and this will become your date time rather than string. So now based on date time, we can extract the year and month out. So we have added the year and month. So this data frame does not have the year and month. So we have added year and month here. We can look into the min and max. Here is our min and max. And now if we would want to save our data set, we could save min and max. So here is our min and max from 2000 to 2020. And that's a CSV file for California. We can save it. If you would want to create the zip file, we could actually create the zip file too. So we have created the California Daily Fire CSV, and that is about 14 meg file, and it has about 221,000 rows. So that's our California data set. And if you would want to validate that, we can again use the Kepler.gl, and this time we are going to use this only California data set. So this is the California Daily Fire, and as you could see here that this data set is only using the California fire. And because the California is actually here, and then we are still going into Nevada, and that is reason because the way this whole split we have created is kind of just trying to check the longitude and latitudes are between some range. So if you would want to split them more nicely, we will have to really work little more differently. So using the shape and all the outer rings of the shape, longitude and latitude, and find the values within that range or not. So that's kind of another exercise for another time, but not needed. So at least now you have whole idea how you could create the data set related with a country and specific to a certain region within the country. That's what we have learned. And we will take this whole learning and we will try to apply this learning for another country called Nepal. And I choose Nepal only because it's a small country, so it will be faster for us to process this data set. So here we are using for Nepal. Most of the code is similar, so I will not be going deeper. I will just only come the place where we are working on Nepal. So as you could see here, all the files we are loading, and most of the data related with Nepal is actually start from Nepal. So we can say, let's take a look at least one file. So here you see, this is a nepal.csv. So we are looking all the files where we have Nepal available and which matches our need. So we just try to focus mostly on nepal.csv. So these are the nepal.csv files. Now we can look into the VIIRS based data for the Nepal, similar, and same thing we do for MODIS. So pretty much same, identical what we have learned with the United States data set. So when we are going to read this code to find all the wildfires in Nepal, it's exactly the same code. Nothing is changed. The only thing we have done is that we only filtered those files which are related with Nepal here. So let's create the data frame for all US files. Okay, so here we have all Nepal files. So these are the all Nepal files. So let's call here all Nepal files. So these are the 31 files we have read, 355,000 rows here, FireDF. We are concatenating. So now we have a data frame, and which is pretty much what we have seen for United States. Acquire date, we are sorting, and brightness, etc. So I will just bypass everything. FRP type confidence. Okay, now we are creating the group by based on these fields. Everything is okay. We are changing here data frame to date time properly. So we got the date, year and month is also added, and we can check the min and max. So here is a data set between 1st November all the way to 31st December 2020. So we are creating this Nepal data frame from 2020 to 2020, and let's save it. Nepal data is available. This is our Nepal data. So like previous exercise, we are going to use this Kepler to validate it. Let's use this Nepal. And here is our Nepal. So as you see that Nepal is just north of India. So this is the Nepal, and here is the wildfire. If you would want to filter on year, you can choose add filter, select a field. You can say year because now we have added year. You can say give me the values only in last. And then as you see here, because we have less data, so we can see the change in values in our graph as we filter the number of years. And reason we could do is because we have added year and month here. If you would want to add filter, you would want to change color, you can go back and you can add these layers, and within these layers you have ability to modify what you would want to do. You would want to put point, you want to select the latitude, so this is the latitude. This you want to put the longitude. Fill color, you want to change the color scheme. You can use, for example, this color scheme. Select a field, you will use the confidence, and here we could actually change the color scheme. Outline, if we would want radius, how big points you want. So as you could see here, points really proves that where this, and if you go a little more deeper, you could see. So there are so many things you could do with Kepler. And outline, we say we don't want to show the outline, and now you have way more better to understand what you are saying. Or if you change this color to something more appropriate, like all colors are different in the range, so red is more visible, so this has more pattern. So this shows that heat this one is better. So where the red is only available in one. And if you would want to add a filter based on confidence, then you could actually do so. You can come here, you can add a filter and select a field. You can say let's have a confidence, and confidence value you reduce it. So you can say give me the high intensity filter only in, sorry, so these are the value above 90 in year last, and that's what you are really going to get, some of these. And thus we have added filter, and we have also added these layers. So there is so many things you could do for making this visualization depending on your need. So we have looked into the data creation. So the way I have created the data set for United States, and then I went to California, and we have created data set for Nepal. You can create this data set for yourself. And if you would want to upload your own wildfire data set for whatever country, you can go to Kaggle, create your own account, and you can update your data set. And if you learn from me, please feel free to put my GitHub also. I would really appreciate that. Thank you in advance. So we have looked into how we have created this data set. We have also created these CSV files. Next, we are going to look into how we can visualize this data set which we have created outside the Kepler. So for example, if you do not have Kepler, you would want to show this data set in your application, how you could do that. So let's look into this show wildfire map Jupyter notebook. And here I'm using this utility called mapboxgl. So mapboxgl is Jupyter mapboxgl. So in order to use the mapbox, you need to have the mapbox access token, which you could create your free account and you can create these tokens. So this is just a test mapbox token, which will not work after this demo because I will reset this. So you need to get your own access token to use this tutorial. I just wanted to show that I do have the mapboxgl installed in this machine. And here is the files we have. And one thing I also wanted to show you that I'm using Python 3.9 for all of these examples. So we are importing the pandas. And as you could see here, there are these data sets available for fire. So we will look into any of these fires. So we have California Delhi fire, this one. So we will use this data set. We can read it. And now we can look into our data frame. So we could read 221,000 rows we have. So we are setting up the mapbox token, which is created here. Then importing the mapboxgl utils and mapboxgl viz. And these are the modules we are using in our project. Here is our data frame. And here is the values for each year data set we have. So if you would want to just show the year 2020, you could filter our data set here, but I will not filter right now. I will just show you everything, which might take little longer. So here we are creating these points. So we are taking the data frame and using the longitude and latitude and selecting these 4 properties to create the points. If you would want, you can actually create the file name here and all these points will be saved to the disk. But if you would want to create these points in memory, so these points are created in memory. Now we are setting this color and color combinations is white to red. And here is we are using the mapbox token. Height of map is 800px and we are using the confidence value as a color property. And color stop is color breaks here, and here is the color breaks range. So because our value is in 100, so we could actually make this value is 50, 70 and 100. That's our color break range. So here widge is defined and let's create the widge. So it's using the mapbox library and here we are creating the map and here is the map for the California region in United States. And that's how you could understand that how we have created our map using mapbox library and by using the mapbox access key also. It's a very simple way for you to understand, and then you can go more deep and you can learn more about it as your need arise. I just wanted to show you that how you could show this data. If you would want to show the Nepal, you can very quickly show the Nepal, or if you just want to filter it, you could filter depending on your year value too. So that's one example I had. So you could show this thing. One example I have the matplotlib library also, which I found very interesting, how you could show the graphs over there. So we are importing some of these important libraries for us. Let's use the California dataset. We have already seen that data frame. So what we are trying to do here is that we are trying to create the scattered map plot and using it's a scatter map using longitude and latitude. Now, if you would want to set the confidence value, this time we are using the confidence value to create the plot based on confidence. So now you could see here that this was just a plain scatter plot, but here the matplotlib is creating the graph based on confidence value. If you would want 20, it could be a little bigger and make it 7 to the 14. So the same graph is little bigger, and here you could see the intensity of the color and where the fire could be. So if you would want to superimpose this map on a California map, you could do it. So I already have this California map available here, and you could use this code, which I have got, I think, one of this location from here or some of these library. So I'm using their code as it is to show this map value. So let's build this map. And here, as you could see here, that California map is behind. You could change this color to anything and you can come up with your own background image. But what it does is just try to take the map image and superimpose top of it. So if you would want to make it a little more bigger, better, you could create it like 20 by 14. And it may not be correct because I'm just using a guesswork here, but you could do a better job here. I just wanted to tell you how it can be done. And here just an example. I just wanted to show you that if you would want to create this scattered map based on entire scattered plot, you could actually do. And I'm just only using 1000 data points to just show. So that's like a side-by-side comparison. In our next step, we are going to create a Streamlit application to build a Python app for our any country wildfire data visualization. So I already have this folder named Wildfire Data Streamlit. I will create a file. I will just call touchapp.py, and for very quick, I will say import Streamlit as st and st.header wildfire app. So that's our app.py, and I already have Python running in this machine. So it's a Python version 3.7, so I need to use the conda to activate Python 3.9. Now I have Python 3.9 in this machine, and if I try to say Streamlit run app.py, and here is the sample Streamlit application we have just started to build. So now let's build the Streamlit application. And in this application, we are going to load the CSV file for any country, and we will try to filter on year, that for which year you would want to create the wildfire visualization, which will be similar to this, or it will be similar to more of this way for any country, and we can select the year to show in this map. I will stop this Streamlit application here, and I will use PyCharm to open this project, and I will be developing code over there. So here is as PyCharm. We are using program wildfire Streamlit, so that will be our project for PyCharm app.py. I will be using Python 3.9, so this is a Python 3.9 runtime, and let me create the configuration. So I will be using the debugger connected with Python 3.9 runtime, so Streamlit can be debugged. I do have a tutorial available at my YouTube channel if you would want to learn how to connect your PyCharm with Streamlit in Python 3.9 to debug your application. So here is our code. If I want to debug it, I will start the debugger, and you will see that we are going to hit this breakpoint when application starts. And as you could see here, so we have hit this breakpoint, and now application is running here. There you go. So you get an idea that how we could build this our app as well too. So one thing I would show you very quickly that I do have GitHub public code, a sample application I have created earlier to create the deep check Streamlit application. The application look like as here. So as you could see here that this application help us to load the CSV file, and then after that you can perform the Panda profiling, and you can read the CSV and then process the data frame, whatever you would want to do. So we are taking the help from this sample code and build our application in this tutorial. So please feel free to visit this sample application which is available here, and that will be very helpful for you to build the Streamlit application. So here is the app.py. So here we are creating the Streamlit main, and it will be title will be Wildfire visualization, and that's our main. Let's define our main. We'll be using this. So that's our main. We need the data loader. Let's create the data loader.py. So data loader, import data loader, and dataset sample. So we can say Wildfire data sample. Second will be our yearly wildfire data and pandas profiling. So that will be second, yearly wildfire data selection. I will walk you through everything just after I complete this. So we need st.write wildfire by year and pandas profiling. So we need pandas profiling. We could add that one too. So just a few lines of code. Let's add pandas profiling.py. That is also added. And we need Streamlit. There you go. So we have created a very quick skeleton application, and whole application is ready now. So data, so we can say wildfire data selection, select the data set, upload. We do not need this wildfire data sample. So let's run the application and see where we are. And as you could see here that this application which we have just created, it has a main. It's create the title and header. So here is the title and here is the header. And the left side we have created this sidebar. So wildfire data selection. So here you could either select a CSV file related with your country data where you have saved this wildfire. So we have saved for California, we have saved for United States, we have also saved for Nepal. So we could use those CSVs in our project. And as you could see here, we have CA, we have USA, and we have Nepal. So we could select any of these. So let's select the Nepal because that is really very small file to try. Nepal file is loaded, and you could see here that we have wildfire data sample, we have yearly wildfire data, so that would be selected here. And then finally, if you want to show the pandas profiling, you could select here. So, and here is our wildfire data sample. So we need to make sure that how is our code. So when you select wildfire data sample, your choice will be here. So this is your wildfire data sample. So what happens when this data set is loaded? We select file uploader. So this whole section is part of st.sidebar file uploader. So the file uploader is created here. Once this file is loaded, that becomes source data, and source data we use data loader dot read load dataset. So we can look into here and basically just call the pd dot read csv. So pandas dot read csv to read this source data, and that what we get back in this df. So when df is active, means data frame is ready, we ask user to provide these three choices and select one of these choices. User select first choice. If first choice is wildfire data sample, we read the data set and we show the 10 rows with that selected data. If the yearly wildfire data set, we need to filter all these year and we need to show, and pandas profiling is here. So let's reload again, select the file. We have selected the file, and as you could see here, the data set is loaded and we already found 40,000 rows and 11 columns in this Nepal data set. And here are the choices. So here is the yearly wildfire, but we have no code here. Only this line is coming here, but there is no data. So we have to work on it, and pandas profiling is here, which just create the profile. I'm not going to run here because it takes some time to create. I will just run at the very last. So let's come back and work on our year. So we already have data frame here. So if you would want to learn more about data frame, there is a couple of things you could do. You can put this breakpoint here. So having breakpoint in your Streamlit application when you are using PyCharm ID is very helpful, and you will see how it helps us. Reload, take this data frame, select wildfire, and we are here. So if you would want to work on our data frame, so this is our data frame, and as you could see here, that's our data frame right now. See, if you would want to see that data frame dot columns, here are our columns. So these are the list of columns. As you could see here, that we do have year and month. So we can select the df years, year. So these are the year value we have. So if we would want to process the year, we need to filter all those years. So we could get the year values. So if we will say all the value, all the unique from here, here you could get all the unique values from the year. So what we could do in this, we will make it run. We will say year, all the year keys will be the df of year. So we got all the keys, and if the length of year keys is greater than 0, it means we were able to get these keys. We will say please select wildfire by year. And now what we need to do is that we need to create a year selection checkbox. So I have a code already available. So let's create the checkbox. So what we need, so you see here, year selection is a year, and we are using the sidebar checkbox, which really shows the years to all the list of years. So that year selection will be the list of years. So let's save this and reload it. That's year, and as you could see here, the list of year is all visible. And how it came back here? Because what we are doing, we are taking this year keys, which is already created here, and we are filling them into the checkbox. So all the year values are. Now what we need is that we need to learn how to find out which one is selected. So next step is, so we could figure it out which value is selected. So we could filter the array first, or the data frame first and then render the map. The next step is this. We will take year selection, so all the items, so that's a dictionary, and we will see if all the values are true. Let's come back here, and that will be the list of all selected years, and we can say if the all selected years is greater than 0, then we can filter. So we can say df equals df of, so df of year is df of year is in all selected years. So df will be, so it's a filtered year. So you see, so we are going to filter all the year value which is selected from the list, and that will be our new df. And when this df will be there, we are going to create the wildfire view. So let's create a new file called wildfire view.py, and from import Streamlit as st and define show wildfire map, and it's going to take a df, and then we say it's st dot map and just try to pass the data frame first, and let's see what happens. So because Streamlit already has the map object, and if you have a data frame which has the key values such as longitude, latitude, or long or lat, it automatically render a map for you. So let's see, we have created this. Now we can import wildfire view, and we can say wildfire view dot show wildfire and pass the df. So this is what we have done, and let's launch it. Select the Nepal Wildfire, and as you could see here, the list of selection is this. So all values are false right now. Run it. Now if I select 2020 year selection, you will see that 2020 is true and rest of the values are false. If I select 2029, you see that 2029 is selected, and then is filtered next. And if the length, so the length is 2 because there should be 2 items, 2020 and 2029. So we are taking this df here and then checking if the year value is in these two lists, is filter the data frame, and then we just print the data frame map here. And here is your data frame. So depending on the Nepal map, you can see that our map is available. So if we try to use, let me remove this breakpoint so we could see. So 2020, 2029, 2028, you see the filtration is happening. More and more data is added. We could remove it so you could see. So it's a very simple code which we have added to create the Streamlit map for any country wildfire visualization. If we would want to cancel this data frame, now we need to use the California, which is about 14 meg. It has 221,000 rows. Let's use the wildfire. Let's select the 2020. Actually, we need to sort it. It's gonna be better then. And here is the California. And as you could see here, we are using the st.map. So if you would want to use the Plotly map or Bukhaya map or anything else, feel free to experiment your code. I have just given you an idea that how you could create a very good Streamlit application to show the wildfire data set depending on whatever country you are interested into. The two examples which I was studying, they were from IBM Spot Challenge Wildfire as well as the H2O.ai. They were using the Australia wildfire in Australia in I think 5 or 7 different regions like New South Wales, Auckland, etc. So but that was that example. But here I'm just using this whole project related with the United States, especially in California wildfire. So this sample could help anyone to go deep into first create the data set and then visualize it. In the next step, we are going to use the machine learning and try to build a model so we could predict the fire where it can be within the United States California region, and we are going to learn the machine learning part of this project. Let's have a quick recap. In this project, so we started our tutorial with the understanding of where the satellite related data is stored, how you could download all the data set. I have shown you everything. Once we downloaded the data set, I showed you that how that expanded data set really look like. So all the data set related with our project for all over countries worldwide from 2020 to 2021 is all available there. Then we use Jupyter notebooks to learn how we could create the data set. First we started for United States, then we zoomed into from United States all the way to California, and then we filter our United States data set to California data, and then we saved both California and United States wildfire data set all the way from 2000 all the way to 2020, and then we saved it. And then after, we also use the same code to generate the data set for Nepal. Once we have created these data sets, we went to Kepler and used the visualization methods available in the Kepler to see our data. And we have learned how to use Kepler in just a very small way. I really didn't go very deep to explain you how you could take advantage of Kepler, open source tool available for you to visualize your geographical data. You could use Kepler for any geographical data set as long as you have longitude and latitude available. Then after, we have learned how to show the wildfire map using the mapboxgl in Jupyter notebook, as well as how to show the graph using the matplotlib. Once we have completed all that, we also study the data set which I have uploaded at Kaggle using the same method. And finally, we created a Streamlit application to read the data set which we have just created in this exercise, and based on year value, we also show the map of wildfire for a specific country, and depending on which year you would want to create it. And all that code which we have generated in this exercise is all available status. So git add. So I'm going to push this whole source code to GitHub. So let's take a look into the GitHub where this whole source code is available. So here is the wildfire project. Here is the Streamlit project. So this is the Streamlit code. I have already pushed everything. Here is the dataset related project I have also pushed into, and because my gitignore has all the CSV, zip and gzip blocked into, so I'm not uploading any of the data, and these wildfire data and zip data is also blocked. So even that data is available in my working folder, but none of that data is being uploaded to GitHub. So these dataset creation and Streamlit application part is already completed. The second part related with the machine learning, I will be adding in the same folder, and I will update this GitHub location also. So that's all we have created in this tutorial. I hope you have enjoyed, and I will definitely like to see you in the second part of this tutorial, where we are going to use the machine learning to predict where the fire could happen, and we could also learn various machine learning ways to have these prediction related with wildfire. So it was the first part of our tutorial where we have generated data set related with wildfire for any country where we would like to apply machine learning to solve the wildfire prediction problem. Second part is even more exciting than the first part, because now we have our data set ready, so we could apply various machine learning algorithm and methodologies to solve our problem. Thank you so much for your time to participate in this first part of tutorial. I'm definitely excited to see you in the second part of the tutorial. Until then, thank you. Thanks for your time. Please like it, share it, and subscribe it.